Funding for this video is made possible by the Department of Education Rice Grants. Hello again, this is instructor Nandima Ture at Community College of Philadelphia. In this video, I'll be doing the continuation of the series of videos on logarithmic function. Our last video converted exponential function into logarithmic function. Hopefully you understood how this is done. In this video, we're doing the opposite. We're going to convert logarithmic function into exponential function. Let's recall the definition of logarithm. Hopefully you've memorized it by now. It says, suppose a is greater than 0 and a does not equal to 1. Well, there's a number x such that log base a of y equal to x if and only if a to the x equal to y. If you remember from the first video of the series, I stated that logarithmic function is the inverse of exponential function. Let's do this example on logarithm. We have 1/3 times 1/3 times 1/3 times 1/3 equal to 1/81. If you notice, we're multiplying a fraction by itself 4 times. How do we multiply fraction, you recall? We take the numerators and multiply them straight across, and then take the denominators and multiply them straight across. So 1 times 1 times 1 times 1, we all know, gives us a product of 1. Now we're going to take the 3 and multiply that by this 3 to give us 9. After that, we can take this 9, multiply by this 3 to give us 27. And lastly, we're going to take the 27, multiply by this 3, and we get a product of 81. So 3 times 3 times 3 times 3 equal to 81. How do we write the 1/3 multiplied by the 1/3 multiplied by 1/3 multiplied by 1/3 equal to 1/81 in logarithmic form and in exponential form? Well, you notice the base is 1/3. You're taking 1/3, you're multiplying it by itself. How many times? 1, 2, 3, 4. You multiply it by itself 4 times to get 81. So in logarithmic form, we will say log base 1/3 of 81 is equal to 4. In exponential form, we'll take the quantity, put parentheses around 1/3, raise that to the 4th power to get 1/81. You must remember the names of the different parts of this notation. We have the exponents, which is the number of times we're multiplying a number by itself. So in this case, the exponent is 4. We have the base, which is the number which we're multiplying by itself. And in this case is 1/3. And lastly, we get the argument, which is the answer we get after we multiply a number by itself numerous times. Let's do this conversion from logarithmic form into exponential form for this example. Log base 3 of 27 equal to 3. Go back to the formula. It says log base a of y equal to x if and only if a to the x is equal to y. So we have log base 3 of 27 equal to 3. Let me use a green for this 3, and let me use blue for this 3 so you can see it clearly. How do we convert it? Well, let's see how it's read. It says log base 3 of 27 is equal to 3. So the bases are 3. So we're going to take 3, raise it. Actually, that should be the green, so you don't get confused. We're going to take 3 and raise it to the 3rd power. That's this 3, the one that I underlined in blue. And we're going to get an answer of 27. Okay? Let's do this example. Log base 4 of 1 over 16 is equal to negative 2. If you notice, our argument, which is the 1 over 16, is a fraction. And recall what I stated before in the first, actually the second video, I stated that if you have a fraction that's an argument, most likely your exponent will be a negative. So you have log base 4 of 1 over 16 is equal to negative 2. So what do? Convert it into exponential form. So we will say the base is 4. So 4 is being raised to what power? To the negative 2, which will give us an answer of 1 over 16. Recall the rules of exponents. It makes sense because the rules of exponents says a raised to the negative n is equal to 1 over a to the positive n. So our a is the 4. So when we take 4 and raise it to the negative 2, to make it positive 2, we'll change it as 1 over 4 squared. And we all know 4 squared means 4 times 4, which gives us 16. So 1 over 16, which is what we got. Let's do another example. Log base 2 of 128 is equal to 7. Convert that into exponential form. So due to the formula, it says log base a of y equal to x if and only if a to the x is equal to y. So our a is the 2. So we're going to write 2 raised to what power? To the 7th. 2 raised to the 7th equal to 128. What does that mean? 2 times 2 times 2 times 2 times 2 times 2 times 2 gives you a product of 128. What about this one? Log of 1 is equal to 0. You're asking yourself, what's my base? Well, recall that log base a plus base 10 of a is the same as log of a. That 10 is what we consider as the common base. So you have log, in a sense, there's a base of 10. Let me write that in red. Log base 10 of 1 is equal to 0. Well, we don't write it as log base 10 of 1. We will just say log of 1. So log of 1 is equal to 0. How do we convert that into exponential form? We call in the formula, which says log base a of y is equal to x if and only if a to the x is equal to y. So our a, which we don't visually see, but mathematically it's there, it's the 10. So 10 raised to what power? The exponent is 0. 10 is raised to the 0 power to give you an answer of 1. Notes from the rules of exponents that says a raised to the 0 power equal to 1, given that a does not equal to 0, because 0 raised to the 0 power is undefined. So it makes sense 10 raised to the 0 power equal to 1. So it's your turn again. I want you to pause this video and do these 3 examples and see what you get. Okay? Let's see how you did. We have log base 7 of 49 equal to 2. Convert it into exponential form. We'll say 7 squared equal to 49. Log base 27 of 3 is equal to 1/3. Written in exponential form says 27 raised to the 1/3 power gives me 3, which is correct. Log of 1, what is that? 1, 2, 3, 4, 5, 6. Log of 1 million is equal to 6. You notice that's the common base of 10. So we can say log base 10 of 1 million equal to 6. So our base is 10. So you write it as 10 raised to the 6th power equal to 1 million. I hope this helps you out. Now take some time and do more examples on conversion from logarithmic function into exponential function and vice versa. The next video of this series will talk about and explain the rules of logarithms. If you recall the rules of exponents, it will be really helpful in our next video.